So in this last video for Chapter 5, we're going to focus on conditional probability and independence. So the first thing we have to do is we have to determine if two events are independent, and when appropriate, use the multiplication rule for independent events to find probabilities. So when knowledge that one event has happened does not change the likelihood that another event will happen, we say that the two events are independent. So two events, A and B, are independent if the occurrence of one event does not change the probability that the other event will happen. So in other words, if A and B are independent, the probability of A, given that B already occurred, is still just the probability of A. Event B doesn't affect it. And the probability that B, given A, occurs is just the probability of B. The probability of A did not affect the probability of B happening. When events A and B are independent, we can simplify the general multiplication rule. So if we are taking two events that are independent and we want to find the probability that A and B both occur, then it's just the probability of A times the probability of B. You don't have to worry about what already happened for the second thing, for the second event. So for an example, following the Space Shuttle Challenger disaster, it was determined that the failure of O-ring joints in the shuttle's booster rockets was to blame. Under cold conditions, it was estimated that the probability that an individual O-ring would function properly was 0.977. Assuming O-ring joints succeed or fail independently, what is the probability that all 6 would function properly? So, since they're independent, we're really finding the probability that joint 1 was good, and joint 2, and joint 3, joint 4, joint 5, and joint 6. Since they're all independent, we can just multiply those individual probabilities together. And since each O-ring has a 0.977 probability of being good, there's an 87% chance, 0.87, that the shuttle would launch safely under similar conditions. And there's a 13% chance that it wouldn't. So that's the basics. I'm also going to do a couple of these examples that are in your packet, but I didn't care for how the PowerPoint slide went through with 5.3a. So we're back to the way we were before. Live and learn. Have a good night.